Thank you very much for joining today's online event about sensor infrastructure with cloud or SCADA integration for secondary substations. I'm here today with Andreas and Norbert from Greenwood Power and will guide you through this web online event. Let's have a look at the agenda. First of all, you have the possibility to ask questions at any time. There's a chat function and also the question and answers function. And there you can type your question. And at the end, after the 30 minutes of this online event, we'll guide you through all your questions. So please feel free to ask at any time. Regarding the agenda, we'll have a little introduction about electrification and the challenges in the distribution network. We are also talking a little bit about a smart local secondary substation. Then we go through sensors for secondary substations and the basics of modern sensor technology and how to use it. And at the end, we talk about data conversion, transmission, how to get the data out of the secondary substation into a SCADA or cloud system. And to make that secure, we also talk about VPN and for large rollouts about device management and infrastructure management. Let's start with electrification. We are moving to all electric world. This means more and more energy is electrified. So we have e-mobility. We have more and more renewables, decentralized renewables that is growing faster and faster. And all our mobility, but also heating and cooling becomes electrical. This is why the demand for electricity will grow much faster compared to coal, gas, and any other. And the major challenge for this is that this is the distribution grid, where you have those renewables, where you also use energy. And this is also going from the medium voltage to the low voltage up to the private household. And the core of this disruption in the energy sector is the secondary substation in the grid. So this is how a secondary substation looks in Germany. There are many other versions that are looking pretty similar. Sometimes we have towers, sometimes they're underground, but at the end, there are many tens of thousands of substations in the distribution grid. In Germany, we are talking about more than 600,000 secondary substations. With the upcoming e-mobility, they will even grow because we need more power conversion in the distribution grid. Can also have a look inside the secondary substation. There we have the conversion from the low voltage to medium voltage and vice versa. And there is also the possibility, you see that on the right side, that you can connect sensors at the medium voltage level, for example. Now we have a little question for you. So what we would like to ask you is if you are installing sensors inside of secondary substations, so in what kind of time intervals do you need the data in the SCADA or cloud system? So the question and answer is open until the end, and then we'll also look at the answers and share the information with you. So let's talk a little bit about the challenges for DSOs. So very important is that DSOs needs to do investment planning and execution, and therefore they need to anticipate the optimal investment, so to reduce investment cost as well. And this is also driven through quite a lot of uncertainty to a lot of integrated variable renewable energy sources, but also that they have to, the DSOs have to get demand-side integration. This means that they can regulate, for example, larger consumers like production facilities and so on, or households. We had that past week in Texas, in the US, where the energy company reduced their air condition because they did not have enough energy. So this would be demand-side integration as one example. And of course, all the e-mobility and the movement to all electric world. And at the same time, they also need to make sure that the grid is stable, that there are no power outages, and that there is data. That's the reason why the responsible of the DSO is beside ensuring that the grid is operating perfectly within its limits, also to coordinate with the transmission grid operators to optimize the system and reduce the cost. And of course, and this is the most important part, the investment planning for the grid. And you can, of course, increase the capacity of the grid, but it would be much smarter and much more lower cost if you can find possibilities for less capacity increase. And this can or have to be digital alternatives. Digital alternatives means that you need to measure data inside of the secondary substation and the total grid, and of course transmit it to centralized systems like SCADA or cloud. Having a look at the smart secondary substation. So you can do a lot of things inside. Until now, many secondary substations are still most of or a lot of copper. So only a few have sensors installed. And if they have sensors installed, they are not integrated. Already some have some kind of power quality, they have some automation inside of the substation. Probably they also are used for smart metering integration, that they connect power line communication to the private households, production facilities, and also renewable energy resources, where they have metering infrastructure. And then there are coming the sensors and measuring devices, for example, from Greenwood Power. In addition to that, because there are so many secondary substations and they are everywhere, you can also use them for local energy storage. You have the infrastructure there already. You can use them for e-mobility and e-charging. Actually, there are also a lot of new secondary substations built for e-mobility. And then you can also increase connectivity, for example, to intelligent street lighting to control the consumption of the street light. So have a communication hub, a regional one. And you can also offer additional services, for example, with urban sensor networks over LoRaWAN. In addition to that, you need to get the data out, and this can be done over 4G LTE. It can also be done over 5G, but you can also use copper ADSL connections or fiber connections. Now I hand over to Norbert, and he will guide us through the different types of sensors that you can install and what kind of advantages there are.
Thank you very much, Jus. Yeah, we saw now some slides about the upcoming smart grid and how to digitize a ringman unit and the secondary energy distribution. To solve this issue, you need to build up a complete chain of measurement devices and transmission devices. And I would like to start from the first part. The first point in the grid is a transducer which transforms the high voltage or high current to a measurement-able signal, let's say a low voltage signal. And for this application, Greenwood Power has developed some product ranges. We have started with sensors for gas-insulated switchgears, which doesn't mean the sensors are inside the gas tank. That means they are for application on switchgears. If you look at the first point for GIS, typically used voltage sensors for the T connectors, which are available at every gas-insulated ring main unit in the cable compartment. Then you can put in current sensors for retrofitting around the cable or for the bushing installation, or let's say price competitive solutions for retrofitting. The same technology, the same inside parts are also available in different shapes. If you go to look at the air insulated switchgears, we have the same insides, but with another outer shape. This means we have one for air insulated switchgears and one for outdoor applications on poles. We're also providing low voltage current sensors because the ring main unit don't only consists of medium voltage. We have also always low voltage inside these units, and there is also a need for low voltage current sensors. In the best case, high quantity, low price, and maybe with correction factors. And some utility companies are also considering what do we really need? Is it necessary to have low voltage current sensors on the secondary side? Or is it still enough to just put a temperature sensor measurement into the place? This is the simple reason the utility companies want to know, do I have an overload there or not? And with this information, they can make switching regulations, or they can foresee the lifetime of components inside the ring main units. Yeah, for these secondary substations, we made products which have some kind of strengths and unique selling points. Very important for utility companies or measurement manufacturer companies is that the sensors are produced according to standard. In this case, we speak about the IEC 61869, and we are providing these sensors according to standard. It might be the point that if we are producing a product according to sensor, we are compatible to every kind of device, but the reality is a little bit more difficult because the connection between a sensor and a measurement device is not always that clear. So in many cases, or let's say in almost every case, we have to customize our products to the device, and the device has also to consider the right sensor that they work together. In the best case, you have a test together to verify if everything is working very well. Utility companies also demanding in the future high temperature range. You can imagine minus 40 degrees is fastly reached in north of Europe, and 80 degrees Celsius is very fast reached in the equatorial zone. So this is a must that we have a big temperature range at the product. Yeah. And the next point is that the products has to have a very, very good price performance ratio. Why? Because we speak here about secondary substations. Jos already mentioned, we speak about 600,000 substations only in Germany. So the quantities for sensors are very high. And it means the utility companies have to look every single euro, or let's say every single cent, if they are thinking about investments. Other important points are that they have products which are very small and short, so that they don't have to rebuild the switch gears. They want to cover most use cases, or let's say as many as possible. For this reason, it's always a good idea to have some sensors in the hand according to the highest accuracy class, 0.2 S for current sensors or 0.2 for voltage sensors. And for sure, there's also a special application that means power quality measurements. These demands have increased in the past years, ranging from 2.5 kilohertz and now going up to 150 kilohertz, which is really a challenge. And it's not mentioned here, but most important for this first part in the chain is that you have a passive system. The utility companies, the end customers used to have an instrument transformer. An instrument transformer can last easily 30 to 40 years. So it will be impossible to convince end customer that you have to build in an active sensor with active electronics, because you come into a situation that this technology, this solution will last maximum 15 years. Then you are at the end of lifetime. So for this reason, we are going for passive technology. We have, at the Greenwood Power, we are focusing on two technologies. For the voltage sensor, we are going for the ohmic mixed capacitive divider. In this picture, you can see the principle of an ohmic divider. You can imagine there is also some capacitance there. If you can reach the ratio R1 to R2 is equal to C1 to C2, you have basically a frequency independent measurement system. And this system is not depending on temperature drifts or lifetime drifts. This is the good thing on a ohmic divider. For sure, you can make also a capacitive divider, but then you have to cope with drifts. This must be, let's say, compensated in some kind of way, which is also a way to solve it. The similar goes for the current sensors. We decided for an inductive coil closed with a shunt resistor. Here, you have initial accuracy. You don't have drifts by influences from magnetic neighbor fields or positioning influences like you have at the Rogowski coil. For the Rogowski coil, for sure, you have one big advantage. You have no saturation. It is small, light, retrofittable, but you have some disadvantages like what I already mentioned. You have some magnetic neighbor fields influences. You have position influences, temperature drifts. All of these influences for Rogowski coil could be compensated. This is for sure. And we see also some tendencies in the market that is accepted in the future, that we have a technology which is not perfect, but could be compensated in the software algorithm. But this is starting now. For the starting point, Greenwood Power has focused on these two robust technologies which are delivering accuracies from the production plant without any need of corrections. So as I mentioned, you cannot buy a current, a voltage sensor from the shop and put it to any kind of device. The reality is that you have to customize, adjust every single sensor to the use case of the end customer. It depends if the use case is a earth fault direction detection, is it load balancing, is it predictive maintenance? Is it revenue measurement, power quality? All these different use cases demands different kind of sensors. So the very important point here to underline, also from Greenwood Power view, is that we are focusing on customer demands, we are focusing on customer definitions, and we are providing these solutions in a very short time. Yeah, last but not least, here we can see a complete chain. On the left side, we see as an example a low voltage current sensor, which transforms the primary current, in this case, maybe from 300, 400, 500 amps to 225 millivolt. The 225 millivolt is an analog signal. It's a sinus wave signal. It's not digital. The sinus wave signal or the sensor is connected, in this case, to a Siemens SICAM FCM, a feeder condition monitor, which is able also to detect earth fault directions in isolated, compensated, or low impedance star point grids. And this device can also provide, for sure, the standard power factors, the actual voltage level and current levels. And with our sensors, this is a package which is closed, and from the FCM, you can make the next step into the chain via Modbus. But now Jos will continue to present this solution. Thank you.
Thank you very much, Norbert. So we now have seen that we get analog values into the FCM, and then we have Modbus, serial Modbus. So it's usually RS-45. And this Modbus can now be converted and transmitted. So what we need to do is we need to convert the Modbus into a protocol that is also a good protocol for northbound communication, for example, over a cellular network or over ADSL and fiber. And this is definitely not Modbus. So what we have to do is to take a protocol, for example, IC104, which is built for this, for utilities, and which most SCADA systems support. So what we can do is we can transmit this protocol over 4G to the SCADA system. In addition to that, there's also the possibility that you want to build a real cloud application, that you want to have more data. So it's also possible to transmit over MQTT via 4G, for example, to a cloud system. This could be, for example, one of the large clouds like Azure and with a IoT app, or AWS from Amazon. But it can also be any other generic cloud that is supporting MQTT as a protocol, and most of cloud applications are doing that. So we can convert the data that is available in the FCM and transmit it easily to another system. The full setup looks even more complex, but it's still quite easy. So we have the different types of sensors, which is low power current transformer, low power voltage transformer, but also low voltage current sensors that are connected to multiple FCMs within the secondary substation. So you usually find between 3 and 10 FCMs in one secondary substation. And they all can be connected over Modbus RTU and the RS-45 bus to one gateway. So one gateway, in this case, the TK600 from Velotech, can take the data, convert the serial data into Ethernet data, and transmit it over a secure connection to the SCADA or cloud system. In addition to that, there is support for the Velotech device management. The Velotech device management can manage the firmware, the configuration of the devices, and have a central management for larger rollouts. In addition to that, we also have the VPN concentrator, which can be also fully automated to set up a secure environment so that you don't have to configure every single device and maintain every single device configuration and so on. And this is called VPN Security Suite from Velotech for the central management of the VPN tunnels. The VPN Security Suite is also integrated with device management, so it's a seamless system. In addition to the serial connection that you have to connect the FCM, you also have 2 Ethernet ports. And those 2 Ethernet ports can be used to connect RTU. It can also be used to connect another measuring device if you're not using FCM but have some meter with the Ethernet port, you can connect it. And then you can also pull data, for example, from Modbus TCP, so an Ethernet-based protocol. This brings a lot of additional advantages if you have VPN and the central device management. So you also have access to the devices remotely. And you can also have a tech-based access, which means that you can authorize only specific persons to access specific devices, or you can have automated software solutions to access those systems. It's all OpenVPN based, and this means it's a high security connection, which can meet the latest standards for energy and grid operators. It also can, for example, meet the very high BSI standards, which are from the German government, the standards for IT security for critical infrastructures. Besides that, you can take SIM cards if you're using a 4G connection, because there's integrated 4G modem. You can use SIM cards from private APNs or with private APNs, which are in a closed network, and run all the software in your dedicated network without any internet breakout for increased security. But you can also take any SIM card and build up a connection over the public network because it's secured over OpenVPN and nobody can read or manipulate the data you're sending. Besides that, if you have the end-to-end connection between the TK600 router and of course also FCM or any Ethernet-based device that is connected to the router, you can also connect monitoring systems over the VPN so that you have, for example, SNMP monitoring, which is also end-to-end and get some kind of visibility of your infrastructure and the health of the infrastructure. Besides that, the management system and VPN security suite follow the API first approach. API first means that any function that you have is also able to access with the software. So you can, for example, have ERP integration, you can have a SCADA integration. And the functions, there are more functions for the APIs than for the actual web interface or manual user management. So it can be fully automated and integrated in your existing systems. Okay, now we are coming to the results of the survey. So what we can see here that we have a pretty similar setup. 15 minutes is winning. So the traditional 15-minute cycle is with 38% on the first place. And then followed by 1 second cycle, which is probably more demanding. I guess we'll talk about that in the question and answer section a little bit more. And then, of course, the 1 minute cycle. So if we're looking that we had the 15-minute cycle in the past and now more or nearly double as many people want to have shorter cycles, it's quite interesting and will be also interesting for the next cloud and SCADA integration systems. Okay, so now we are at the end of the session and it's open for questions and answers. Andreas, do we have any questions already?
Yes, we do. And I would start with the first question. That's something for Norbert. Is there a digital current and voltage sensor, and in which area they are used? Or does it make sense, basically, to maybe from my side as well, to use a digital sensor?
Okay, thanks for the question. This is a nice question, but the answer is not so easy. Apparently, there is no solution in the market for a digital sensor, as far as I know. Maybe there is a special solution, but there are some reasons because there are no digital sensors on the market at the moment. Imagine if we start from the medium voltage side, imagine you have a digital voltage sensor and a digital current sensor. So now you have two digital streams from these two sensors. And now you stream these values because they are digital over some router to a SCADA or to a cloud application. Now, think about the use cases. Most of the use cases in the grid are earth fault direction detection. How you can make this use case anymore when you have no synchronization between the values of a voltage sensor and a current sensor? For sure, you can synchronize the digital values, but this takes very high efforts to synchronize for the first step. Then you have you have a lag. You have the digitalization of the signals. You send it to some kind of platform, cloud or SCADA. You make the calculations. You say, here I have an earth fault, and then you trigger it back to the ringman unit. So if we consider the use case earth fault direction detection, it's a challenge to have a digital sensor, to use a digital sensor, because the earth fault direction detection device is always near the medium switchgear. and there are directly connected the sensors. If you make the turnaround to a SCADA platform, to a cloud, you will lose accuracy, you will lose time, and you will have additional challenges in synchronization. Okay, this is for medium voltage. I don't see a digital sensor for medium voltage if it comes to this kind of application. If it comes to other use cases, like I just want to know the voltage and the current, I'm not interested in the power factor, it's a solution, yeah. But if a utility company wants to have also the power factor, and this is very often the case, you need again synchronization. If we go down to the low voltage area, it might make more sense, to be honest, because on the low voltage side, the biggest use case is load management. So in this use case, you don't need to have the values every second. It's enough to have it every 15 seconds. So in this case, it could be enough to have just 3 current sensors there to send the data digital every 15 minutes, and it doesn't matter if they are synchronized or not. Yeah. So I think it will come, but just consider in the background, we speak then about active sensors. Active sensors, we speak about reduced lifetime. And this must be accepted from the end customer, that they have to replace these products twice as often as for the standard sensors on the market. And I'm not sure if this is going to be accepted in the market in the future, but we see some tendencies, this is right. There is no actual solution in the market.
Okay, thanks, Norbert. Now, basically the next 2 questions are for Jos. First is a question: what SCADA do you use, or basically to which SCADA systems you can connect? Probably might be an additional question from my side.
Okay, so there are different SCADA systems in the market for energy, and usually they all support 104, at least in Europe. As long as you support 104 protocol and fulfill the general standards, we can connect to that SCADA system. I know that our customers, so we are not directly doing it ourselves, but our customers tried it, I think, with a solution from PSI and another one from Copper Data, as far as I know. But in general, all solutions can be connected. We are not using SCADA systems, as mentioned before, but the standards one are open and should be integrated. If it comes to cloud systems, as alternative to SCADA systems over MQTT, by the way, you can do both at the same time. Then we support all with MQTT, and there's special integrations and deep integrations with Microsoft Azure and Amazon AWS.
Thanks. And the next one is again for you, Jos. It's do you have a router or a switch for fiber optic networks?
We have switches for fiber optic networks, but usually we are going over connectors, so media converters. So you can get the solution also without cellular module inside. And then just connect to a direct fiber to copper converter.
Okay, thanks. The next one is maybe also interesting for everybody, and I will answer them. It's more a generic question. If this presentation will be available later on as well. Yes, we can. I guess we can send it to the participants, and also it will be available on YouTube or as well on our homepages from Velotech and Greenwood Power. And then another question which popped in. It's a question for both of you, and maybe I start with Norbert. We saw now the solution with the Siemens FCM, let's say in the middle, and question is basically, is it also possible to connect the sensors to other devices? And on the other side, from yours to you, is it also possible that you collect the data from another device? So, but maybe Norbert, you start first.
Yep, definitely yes. There are, let's say, many devices out in the market, the category is different. We saw here an example, the Siemens device. It's an earthfall detection device. This is, let's say, one product category which is mainly used in the medium voltage side of a switchgear. For the low voltage side, there are different devices, and if we go a step up, if we speak about protection functions, there's also a complete different category of device. But what all these devices have in common, they could or should understand the IEC standard. So if they look at the IEC standard and see, I need 2 megaohm 50 picofarad input impedance to have the sensors working at my device, and I need the 3.25 voltage level for voltage sensors and the 225 millivolt for current sensors. There are not so many parameters. The IED manufacturers can easily adapt to these parameters, and they are basically immediately compatible to products of Greenwood Power or even our competitors. Yeah. So only things to consider is like how does the plug look like? Is it RG45? Is it open clamp? How long is the cable? Should I have to consider the cable in the inaccuracy of the complete chain? So there is always some discussion needed when it comes to an use case, to a final configuration, but basically any kind of device could be used with these non-conventional instrument transformers from our side.
Okay, thanks, Norbert. And Jos, from your side.
Yes, so all those devices that Norbert just mentioned usually have a serial or Ethernet interface. And this allows us to connect those devices over RS-232, RS-485, or Ethernet. In case of the protocols, as far as I know, most of the devices in the market work with Modbus, or at least offer Modbus as well. So what we can do is we can get or read the registers within the device over Modbus TCP or Modbus RTU, and then everything will proceed as described before. In addition to that, some of the newer devices also directly support MQTT or 104, so they can have end-to-end connection. So the TK600 will not convert the protocol and just work as a gateway. And we can also combine all of those functions at the same time.
Oh, thanks. The next question, and you might, Jos, you might see it as well in the F&A section. Is there a power plant control system, for example, for renewables?
Well, a difficult question. So a power plant control system would be the SCADA, more or less. And of course, it needs sensors, and it needs to have some kind of connectivity of those sensors. For power plant control system, you usually have it locally. So you would not take the way over 4G network. But I'm pretty sure that Norbert sensors can also be used in power plants for the current and voltage measurements there.
Norbert, maybe from your side, I guess we see if we see power plant control, what we recognize now from the market is basically in wind power plants that the sensors are interesting. As far as I remember, maybe you have a word for that as well.
Yeah, I mean the offshore power plants in northern of Europe, they're using usually higher voltage levels. To be honest, they are not satisfied with 24 kV insulation levels. They are going up to 52, even 70 kV insulation level. This would need a special class of sensor for considering the voltage sensor. For current sensor, it's not that important because the current sensor is always sitting somewhere around where we have a screening separation from the primary conductor. And It's a big, let's say, it's a demand, but it's not so big at the moment, and there would be a special sensor needed, what we don't have at the moment, but we are open. If we see some kind of project which makes sense, we go for it. Yeah, this is typically like the class F voltage sensor and the ring type current sensor.
Okay, thanks for that. And again, Jos, the next two questions coming from Aitor. The first one, do JO MQTT, and the next one, do you know of any application using MQTT to control remotely secondary substation, or is it used only for monitoring?
Okay. So I think the first one is if we do MQTT, and yes, we do MQTT, and we can do IC104 and MQTT at the same time. And with MQTT, you can also control secondary substations. It would perfectly work. You would move your intelligence from a traditional SCADA into a cloud system, or your traditional SCADA system also directly supports MQTT. At the end, MQTT is very similar to IC104, at least in the basic functionality. They're both northbound protocols. So it can be used for control. But until now, I just know it from monitoring. So I don't know anybody that is using that control. I was talking to very large IT companies, and they want to offer this to energy companies as some kind of service approach. And I expect that they will use MQTT then instead of the traditional protocols from the energy markets.
Hey, thanks, Jos. Next question is, it is connected to the grid for automatic balance the grid, getting frequency, etc. Maybe a question for both of you, basically. Yes, we are connected to the grid, but and we can monitor frequency and so on. But question would be most likely if we can balance the grid with the solution, or is basically then we are the provider only for the data. But maybe Norbert, from your point of view on that.
Yeah, one big use case for sure, to have sensors and an IED inside a secondary ringman unit is to have some kind of balance regulations. The best case is that you do balance the voltage. You have some limits given by law, plus minus 10%, which must be held. And to keep this band under control, you could use the voltage sensors that you make the measurement. You have 0.5% accuracy. Maybe you have a switchable distribution transformer where you can really balance the voltage directly inside the ringman unit. Otherwise, you have the tap changer on the primary energy distribution to regulate the complete stream, the secondary stream, or you have also the choice to balance and regulate on the low voltage side with line feeders to lift or to bring it down the voltage level of every single phase. And there are some additional use cases in the future. Think about the frequency converters of households. You can if you connect it to some kind of, in this case, I would say cloud system. You can use the frequency converters of the households to control the cosinus phi factor of the input power of the photovoltaic modules, to put more energy into the grid. So this is also an opportunity to make such kind of regulation. And it's not an automatic feature in what we present today, that we have some kind of balance algorithm. It's, let's say, a basic a basis. If we put our presented solution, the complete chain there, you have the possibility with the data in the cloud to do some regulating algorithms. Yeah. Always considering what kind of sensors are installed in place. Yeah. You will fail if you install a voltage sensor with only class 1 and you have a device with additional 2-3% inaccuracy and an additional inaccuracy by cables and input impedance. So we have 5% inaccuracy. Then this use case makes no sense anymore. So this must be considered during the first discussions. Then you can set up on top on this solution some kind of these algorithms.
Okay, thanks, Norbert. Then the next question for Jos. OPCUA pub sub being supported for cloud communication? Question mark.
Yes. So publish and subscribe from OPCUA is not supported yet, but it's under development. So as soon as we have a project behind, we can realize it pretty fast. So please get in contact with us, and then we'll discuss your requirements and check if it could be done and realized.
Thanks for that. Next one for Norbert. Is there any use case of Greenwood Power sensors in metered ring main units?
Yeah, we speak about revenue measurement. We speak about current sensors class 0.2S, 0.5S, which are necessary to make some kind of metering or revenue measurement. Yes, we can provide such kind of products. There is only one challenge. There is in Europe, as far as I know, no official institute which could confirm this high accuracy class at the moment. This is the major problem at the moment. But the products could be produced and delivered with such high needed accuracy classes, and could be also connected to metering devices for sure. I got some inquiries in the past, and we also delivered some 0.5S sensors. So it depends also heavily on the local regulations and the regulations inside the country. In Germany and Austria, I have some doubts that we can deliver sensors for metering. In the rest of the world, it might be different.
Yeah, I guess as well that there might be local institutes in different countries which might do the test. Yeah, depending on the application, and if someone wants to know more about it, then we need to speak basically about the country, and then we would see. And then I have another question, and this is for Jos. How many devices could be handled via your device management system?
This is mainly, unlimited. So the largest installations have more than 10,000 units in it that are managed at the same time, and also build up VPN connections. The software is built that it can scale. So depending on the servers or cloud infrastructure or the computing power you have, and probably the redundancy you build up, we can manage as many devices as needed. Okay,
cool. And then another question, which is more or less goes in this similar direction, let's say. Is it possible also to connect two devices via Ethernet?
Yes, so we have two Ethernet ports on it. You can configure both Ethernet ports separately. So you can have two devices, you can have two subnets connected to it. If you need more Ethernet devices, you can also add a switch. So you can also have multiple IP addresses on each port. So it's a very flexible setup.
Awesome. Great. So basically, as far as I can see at the moment, we are through all of the questions. If someone has more questions, please feel free to contact us afterwards as well. And handing over for the last words to Jos.
Andreas, thank you very much. Thank you all participants for joining. If you have any questions, please feel free to contact Norbert, Andreas, or me at any time. You'll find our contact details over our companies, and you can just fill out the contact form there, and then we'll come back to you as fast as possible. Also, Norbert, thank you very much for this interesting introduction. And if you have projects, requirements, want to discuss further, please come to us, and Norbert and I will guide you through. Perfect. Thanks a lot. And bye-bye.
Thank you very much.
Bye-bye. Bye.
Bye-bye.